So deriving what the derivative of log base a is, first off, we're going to write it as the exponential statement. I know you learned this a long time ago. It's base a to the y power equals x. So there it is. So if I take the derivative with respect to x on both sides, this is the derivative of a to the stuff. So you know that's a to the stuff times ln of a times the derivative of stuff, which is y prime. And this right-hand side gives me 1. So then if I want to solve for y prime, I'm going to divide through by a to the y and ln of a. And I remember a to the y is equal to x. There it is right there. So this is the derivative. So if my y, here it is, if I take my function is log base a of x, my derivative is 1 over x ln of a. What if it's not just an x? What if it's a log base a of g of x? I carry the g of x along, do the 1 over the ln of a, and I multiply by the derivative of the g of x. Okay, you know log base e of x is ln of x. And you know that ln of e is 1. And so if I do log base e, ln of e is 1. And so that would just give me, using this one, log base e, ln of e is 1. So I would just get 1 over x. And so the derivative of ln of x is 1 over x. You're going to need to know that a lot. Derivative of ln of g of x is 1 over g of x times g prime. And this is just a different way of saying, if I have a u, which could be a g, a function u that's not an x, it's 1 over stuff times the derivative of stuff. So it's not much different than this at all, except I'm using u for g of x. This is the same as this. So what the deal is if there's absolute value bars around the argument of the ln, you do not carry the absolute value bars. It's just 1 over x. Same thing if it's ln of absolute value of g of x. You just take 1 over stuff times the derivative of stuff. So these are the very important log properties that you need to know. So let's go start taking a derivative. So the derivative here would be 1 over stuff times the derivative of stuff. And that's it. And here, 1 over the 3x minus 2, the stuff, and then I have an ln of 3. Remember, it's always the ln of the number, and then times the derivative of the stuff, and that would give me a 3. Here, if I want to take the derivative, I take the derivative of this ln, which is 1 over stuff, so the stuff is ln. Now I take the derivative of stuff, so I multiply by the derivative of stuff. Derivative of ln is 1 over x. So you're at the absolute values, so you know when you take the derivative, there's no absolute values in the derivative. So it's 1 over 5x to the 4th plus 4, right? 1 over stuff, times the derivative of stuff, which would be 20x cubed. And that's it. Okay, so here, remember, it's when I have ln of t to the 4th, that's when it's 4 ln of t. This, if I rewrite it, it's the same as saying ln of t all to the 1/2 power. So the log rules do not apply. So in order to do this derivative, we just need to use product rule. So first, d second, bring the 1/2 down, subtract 1 from the exponent, and then multiply by the derivative of the inside, which derivative of ln of t is 1 over t, plus ln of t to the 1/2 power times the derivative of t squared, 2t, and that's a fine answer. Okay, this one here, the log properties do apply, so let's use it. So y prime, let's just rewrite y first. Sorry, I meant to say that. ln of t to the 1/2, and so that's the same as saying put the 1/2 down in front, right? T squared times 1/2 ln of t, and I'm even going to make it like a 1/2 t squared ln of t. The more you simplify before you go take the derivative, the easier it'll be. So this will be my first and second function, because I can see there's going to be a product rule. So y prime will give me first d second, which is 1 over t, plus second d first, so I bring that 2 down, and I just get times the t. This one's just kind of screaming to be fixed, so I'm just going to do it. So I see the t's canceling, so I get a 1/2 t plus, and you know this t doesn't go inside, so it's t ln of t. And that's it. So here we've got, looks like quotient rule, right? So let's go do it. So low ln of t, d high, which is a 1, minus high, d low, and then square the bottom, and off you go. So that's for the first of the two functions. So if I take the derivative of this, I get low, d high, that's a 0, right? Minus high, d low, square the bottom, and off you go. So let's simplify this a little bit. So I get ln of t minus 1 over ln of t squared from this one, right? Just do the weird color change. Okay, so I got this subtract. This is 0. This gives me a minus of 4 over a t, and then ln of t all squared. It doesn't look like anything's going to combine, so I'm just going to leave it as it is. Okay, so let's make sure we're all good with playing with numbers. So if I want to take the derivative of this, I'd have low, d high, 1 over x, and then minus 1 over x, minus high, d low, which would be 1 over x, because the derivative of the number e is 0, divided by the denominator squared. And then there's nothing left to happen for that, so I can just leave it just like that. Okay, so these are the ones you really want to use log properties first. So I see a multiplication on the inside. So let's remember ln of a times b is the same as saying ln of a plus ln of b. So this could be rewritten. Make sure you're keeping it as y equal ln of x squared plus ln of sine cubed x. Oh, wait a second. Don't I know that ln of a to the r is equal to r ln of a? I can bring this down in the front. So 2 ln of x, I'm not doing the derivative right. So I'm just bringing numbers down in the front. So this is on the sine, which is the argument. So I'd have 3 ln of sine of x. Now I'm going to take the derivative. It's going to be so much easier. So the derivative will be carry the number 2. The derivative of this would be 1 over x. Carry the number 3. Take the derivative of ln of stuff is 1 over stuff times the derivative of stuff. And that would be it.